Unit 9, Target 4, homework number 16. Solve the right triangle. Round decimal answers to the nearest tenth. We have two sides of a right triangle. When we have two sides of a right triangle, we can use the Pythagorean theorem to find the third side. So the side that I'm missing is lowercase g. It's across from capital G, the angle. So we're going to call that lowercase g. For the Pythagorean theorem, I'm going to say that I have one leg, 14 squared, plus another leg, g squared, is equal to my hypotenuse, 16 squared. Make sure that you have the hypotenuse by itself. Okay, you can use your calculator. 14 squared is going to be 196 plus the g squared. The 16 squared is, I think, 256. Double check that. So 256 equals 196 plus g squared. You're going to subtract 196 on both sides. G squared is equal to 60. We take the square root of both sides. G equals the square root of 60. Square root of 60 breaks down to square root of 4 times square root of 15. So 2 square root 15 is the exact answer. We might ask you to do that on the test because you've been doing that for us. You can also type in the square root of 60 on your calculator and see what you get there, because they said you could round to the nearest tenth. So you have 7.7 as an answer rounded to the nearest tenth. So G is equal to 7.7. Next, I want to find the measure of angle G and the measure of angle J. Solving the triangle means find all the sides and angles. So the summary that we had in class was whether or not you're looking for sides or angles. I highlighted in blue for this one. If you have the side lengths and you're finding the angle, you're going to use the inverse sine, inverse cosine, inverse tangent. So I have the side lengths. I'm specifically going to use the 14 and the 16 just in case I made a mistake while I was finding G. That way I'm using accurate numbers. From angle G's perspective, I have the hypotenuse, which is 16. I have the adjacent side, which is 14. And so I'm going to use adjacent and hypotenuse, which is the cosine. So cosine of angle G is going to be the adjacent over the hypotenuse, 14 over 16. So there is some angle G whose cosine is equal to whatever 14 divided by 16 is. 14 divided by 16 is about 0.9. So I'm looking for the angle that makes that happen. So I take the inverse cosine, the 14/16, or 7/8, and I type that in for G. So inverse cosine, 14/16, second cosine, 14/16, and I get 28.95. So rounded to the nearest tenth would make this go to 28.10, which doesn't make sense because the 5 would make the 9 go up. So actually rounded to the nearest tenth, this is rounded to 29 degrees because it would go to 29.0. So 29 degrees is the angle I'm going to use for angle G. Then to find the measure of angle J, I could do the same thing, but instead of cosine, I would be using sine. From J's perspective, instead of the adjacent, this is the opposite side. And so I could say sine of J is equal to the opposite, 14, over the hypotenuse, 16. And I could then do the inverse sine of 14/16. Or draw your attention down here on the right in green. Once you have one angle measure besides the right angle, you can subtract it from 90 to find the other. So 90 minus 29 is equal to 61 degrees. So J is going to be 61 degrees. If you do the inverse sine of 14 over 16, I did that wrong. And I need to clear that. Inverse sine of 14 over 16. Pressed too many 6's last time. I get that 61.0. So it is 61 degrees. You can check this setting up a trig equation kind of out of space here. So I'm not going to show that. If you want to see how to check it, go check out one of the videos from 13 through 15.